All right, so different venue. Hopefully this will work a little bit better. I think I'll kind of start out just some general stuff about the exam, and then we'll kind of move forward from there. Just work through some of the practice exams. So for your section, this will make a little more sense. I've got sections on different days. But to kind of give you guys some flexibility, we'll meet Thursday, so that'll be the last. We'll do some more review. That afternoon, I'll get the exam posted. So you basically can take it any day Thursday, or any day, anytime Thursday, anytime Friday, anytime Saturday, anytime Sunday you want, right? It's going to have a pretty wide range of days that it's open, right? Once you start, I don't have it finalized yet. I'm still working on switching out a few questions and getting the difficulty where I want it. But you'll have somewhere between an hour 15, hour 30 minutes to complete it, right? But it's once you open it, you got the hour 15, hour and 30 minutes, right? And like I said, Thursday, I'll have the exact time, and it'll be posted. Like when I post the exam, you'll be able to see it. It pops up just like our online quizzes do on Canvas, so it's all going to be on Canvas. It's going to be, right now I've got it between 15 and 20 multiple questions, so somewhere in there. Those are going to be, you just answer, it's correct if you get it correct. If it's incorrect, you get it incorrect. But then I'll have one or two short answer, which will have a couple parts to them. So I say one or two, I'm toying around with just having one big short answer and having like parts A through D or A through E, something like that. Now those, I want you to show me all of your work, because the reason why I'm doing that is I want to be able to give some partial credit, right? But if you don't show me your work and you get the answer wrong, I can't give any partial credit there. So how are you going to do your work? Usually I would say 70% of people probably just do this by hand and then take photos and upload it, right? Some people will kind of scan PDFs of their work and upload those. That's a little bit harder to do because you've got a certain time frame. If you don't have something you can scan it with, I get that's not a very common option. Or if you want to type out your work in Word, or kind of upload an Excel file where you were kind of using it as a calculator so that I can see all the formulas that you were using, that's fine as well. So usually Excel, Word documents, but probably the most common, like I said, if you're doing this work by hand, just taking photos and uploading those photos, right? I've never had any problems with it, fingers crossed, with these uploads in the past. It's pretty easy, I think, on Canvas. It's just like, I don't know, if you had an assignment where you have to do an upload, it's very similar. Okay? Any questions on anything I just said there? All right, so like I said, open on Thursday afternoon and get on whatever fits your schedule from there to the end of the day on Sunday. Now you have to be careful. It's due at the end of the day Sunday, so if you have an hour and 30 minutes to take it, you have to start it by 10:30 to get that full hour and 30 minutes, right? Oh, we got one more person. So what I'm going to do with you.
Sorry.
No, it's okay. Let me think how I want to do this. You can sit. Just pull that front seat forward a little bit, and then sit in the one that's in the middle, and we'll say that'll be pull as far. And you can like tilt it if you want, so it's a little bit easier to see. Yep, and then just like you can tilt it so you can see the screen a little better. You're about 6 feet away. So I'm not going to use a lockdown browser, right? We won't be using that. So you can have Excel available to you. You can pull up kind of lecture slides. You'll have a lot of resources available to you. So what that probably means is, relative to if we were taking this in class, might be a little bit more difficult, right? Because you'll have, now I'm not going to make it a lot more difficult, but I may push it a little bit further than I would in kind of standard semester, because you have all those resources available to you. So make sure you have kind of the formula sheet pulled up. Make sure that you've got kind of the materials in front of you that you want, and I don't think it should be too bad. Okay. So speaking of the formula sheet, if we go here on Canvas, it's been up there for a while, but in that exact exam 1 practice materials, here's those formula sheets. I basically put every formula we've ever looked at in this class into one file, okay? Now, will you need all of them? Maybe not, right? But they'll all be there in one central location for you. If you pull this up on Canvas, I don't know why. It's not compatible. It looks goofy on the web browser. If you download it and you look at the actual file, it'll take care of itself, right? So I don't know why it does that on the web browser. If you want to view the PDF, it looks fine in the web browser, but I would download that file just to make it a little bit easier ahead of time. Because as we work through these problems, what I would do is kind of right next to it, or today as you're taking notes, kind of make sure you write some notes down as we're working through this. But I'd print this out and start writing down next to these equations what exactly they're calculating, right? That way you have a sheet where it's not just these all these formulas, you remember, oh, down here, these are our binomial function formulas. Here's our weighted mean and our weighted variance, right? Write that out and have that ready to go so it's a little bit easier to identify that formula you might need for any particular problem, okay? Any other questions from you related to the exam or anything that I've said here? Make sure I have the chat over here. Okay, so what we're going to do today is start working through practice exam B problems, okay? I don't know how far we'll get. I think we'll probably get a good majority of it done. If you start looking on the YouTube page, I didn't post them yet because I didn't want anyone to not understand what was going on. I have multiple sections. So what I'm going to do is I'm doing different exams in different sections. So you guys, I'll work through exam B. And if we have time, then on Thursday, I'll start working through practice exam A with you. But up on the YouTube page will be every single question from either one of those exams somewhere, right? So like yesterday, I filmed and I'll post them after class today. Like questions 5 through 9 and questions 14 through 17 or 18, I'll post those as separate videos. So you almost end up probably with like 5, 6 videos that have different sections of each practice exam. Right? So by the end of the class Thursday here, I'll have posted every single problem from those practice exams in a video. Right? Now they're not, each question's not a video. It's like 5 questions in one. But as you're working through them, that allows you to kind of know, I get stuck on this problem, I can go to this video, find where it starts working through that problem and kind of follow along there, right? So those would be a good resource, but like I said, some of them will come from not being recorded in this class, so that might, I didn't want to confuse anyone with that, but those I'll be kind of posting those up there as I get those recorded. I'll actually probably, even though tomorrow's a study day, I actually am going to record me working through some of those problems tomorrow, just so I make sure I get every single problem up there that we could ever want to look at, okay? Any other questions from me before we kind of start working through some here? All right, so before we jump to the practice exams, well, actually, let me double check. I think there's one on here. We might actually just start there at the end. Okay, so we don't have is a Poisson distribution problem, which is kind of where we left off. So let's just pick up with some of those. So we did talk about the Poisson distribution, which was looking for the probability of different numbers of occurrences over a certain time interval. Usually, like I said, I'm always going to use time examples, but we could do space examples as well. So let's say I have this scenario where, I don't know, let's say 5 people get struck and killed by lightning every year. So I can kind of think about every year, on average, I see 5 people get struck and killed by lightning in the US. If I then want to say, okay, what's the probability, 3 people get struck and killed by lightning in this following year? Well, I know what the average is. I know the number of occurrences I want to find the probability of. We'll go back to that formula sheet, and I'll show you where that's at once we kind of switch off of this. All that is doing is simply, lambda to the x, e to the negative lambda over x factorial, right? So all I would have to do is, got my lambda of 5, my x is 3, e to the negative lambda over x factorial, right? And that would give me the probability of seeing exactly 3 people struck and killed by lightning this year. Right? So that's kind of where we left off with those types of examples. Okay, so what if instead, and this will help you on, I think, one of the very last connect problems. What if I wanted to know, okay, well, I jumped the gun here. What if I wanted to know the probability that, I don't know, I see 1 person killed this month, right? So I'm then asked, okay, what's the probability that 1 person is struck and killed by lightning this month? Well, I only have the average for the year, right? So how could I get the average number of people struck and killed by lightning in a month?
Divide by 12.
Yeah, just divide by 12, right? If 5 people are killed every year, on average, 5 over 12 people are killed every month, right? So I'm just going to convert my lambda, or my average, to what my new time interval is, right? And I'll always kind of assume, like in this one, I'm assuming it's equally as likely struck and killed by lightning in any month. I don't know, maybe for the example of lightning that doesn't work, but kind of if I have an example, it'll be that whatever new interval we're going to, we assume that it's just equally as likely every month to get struck and killed by lightning. So now I have my new lambda, I have my x, I'm still using that same equation. So now it would just be what? Lambda to the x, which x is 1 here, so that makes it a little bit easy. E to the negative lambda over x, or x factorial, which would be 1 factorial here. So the only additional step is that we just have to convert our lambda, okay? Now, if we're ever going from, let me make sure I keep this on here, a larger to a smaller time interval, right? We want to kind of go from a year to a month, right? We're decreasing the time interval we're looking at. We're going to divide, right? What are we going to divide by? Well, it depends on what we're doing here. Here, if we're going from a year to a month, we divide by 12. If I'm going from an hour to a minute, I would divide by, how many minutes are an hour? 60, right? So I divide by 60. Week to a day, divide by 7, right? I'm never going to give you something like, I don't know, kilos to pounds or something like that. I'm always going to kind of use this like, week to a day, year to a month, or something with an easy factor. In fact, when I ask the question in the exam, I'll probably even tell you something stupid like there's 12 months in a year, right? Just to make sure we all know what that conversion factor should be. Okay? So what if I had a similar example, but instead, maybe I'm asked, what's the probability I see, I don't know, 20 people struck and killed by lightning in the next 5 years, right? Well, if I know the average people struck and killed every year is 5, how many people on average would be struck and killed every 5 years, right? So I want to find my 5-year lambda. That would simply be that original 5 times going from 1 to 5 years, so I have to multiply by 5. Okay? So anytime we want to go from smaller to a larger time interval, there, all we do is multiply to get our new lambda, okay? Or our new average rate for that time interval. Is that clear? Any questions on that? So it's like one additional wrinkle in those Poisson distribution examples, but really, I mean, it's not anything terribly difficult here, right? Like I said, I'll keep the time, the factors pretty easy, weeks to a day, or, I don't know, months to a year or something like that, okay? Any questions on this? All right, so if we're good with that, I'm going to actually just minimize this so you guys on Zoom don't have to look at me. Let's go to practice exam B. And I'm not going to start out with the very first few questions because I think they're older stuff, but I think they're relatively easy. Okay? So let's say I start out with an example like this. Right? Oh, what example, right? Give this 2 seconds to catch up to us here. So let's say I start out with a joint probability table. So we'll do some review of what those tables are like and how we can use them to answer different questions. Okay? So here I've got my events are, does someone want marijuana legalized, yes or no? And are they kind of a registered Republican, yes or no? Okay? So the way that we read this table, we said the totals represent the probabilities of whatever the events are in the row or column heading. So the probability somebody wants marijuana legalized, so yes, they want it legalized, is 0.55. Okay. The probability that someone is a Republican is 0.5 in this example. The top 4 left cells here all represented the probability of intersections, right? This event and this event. Okay. So probably someone wants marijuana legalized and is a Republican would be 0.15. Right? So that's just kind of a review of how we read that table. So what if I left out a value here? Right? There's a principle that we talked about in class where I could find what that missing value of x is. So how could I maybe find that missing value of x? Yeah, so if we remember, and I'll just type this because it makes it a little bit easier. We said that to reproduce, like let's say I didn't have these totals. How could I fill those in? We said we can simply add across the rows and then down the column. So 0.35 plus 0.1, that's how we got that 0.45. So 0.15 plus x should give us that 0.55. Okay? So 0.15 plus x will be equal to that total of 0.55. Do a little bit of algebra, and x would be 0.55 minus 0.15 or 0.4. Okay. There's another way I could have done this. I could add down the columns. So x plus 0.1 had to be equal to 0.5. Sure enough, what plus 0.1 gets me 0.5? 0.4. So it doesn't matter either way I want to solve for that one, adding down the column or across the rows, I'll still get the same answer. Right? Just two different ways of doing the same thing. Okay? Any questions on that? Okay with that? So what's the probability that an individual wants marijuana? Oh, so I guess if as we go through these, I'll try to bold the answers. So if we're falling a little bit behind, we still have that. So what's the probability an individual wants marijuana legalized given that they're a Republican, right? So this is a scenario where we're looking for a conditional probability. So I'm going to just blow this up so you can kind of see me working along as I'm talking here. So what we were asked to find, it's always good to kind of write out what you're looking for. So whenever we see this word given, we should automatically be thinking about, we have a conditional probability. What were we given? Well, that this person was a Republican. Or up here, right, calling Republican the event R, so that way you can kind of, that's the notation I'm going to use. Okay. So I want, given that they're a Republican, what's the probability that they want marijuana legalized? So I want to know the probability that they want marijuana legalized, and I could even say LM is equal to yes here if I just want to keep this a little bit more clear for myself, given that they're a Republican. Right? So how can I find that? Well, if we go to the formula sheet, right? Now, one thing I said I'd mention earlier, the Poisson distribution equation that I referenced earlier is down here on the formula sheet. So all the way in that bottom right corner, we have that Poisson distribution equation. But now what we're going to be looking for is, how can I solve for a conditional probability? That equation's right here, right? A conditional probability is simply the intersection of these two events divided by what I'm conditioning on, okay? So here, I'm going to be looking for the intersection of my two events and then divide by, well, what did I condition on, right? That's what's on the right-hand side of that line. So I conditioned on being Republican, so I divide by the probability that they're a Republican. Okay. Any questions on any of that? Shouldn't be too bad. So once we have that general form of the equation, I think it's always beneficial. Just write it out in the context of your example. Now when we go back here, what's the probability someone wants marijuana legalized and they're a Republican? Legalized Republican, 0.15. So got that numerator. What's just the probability that they're a Republican? So what are we dividing by? So yes, Republican. Down here, divide by 0.5. And we get that conditional probability is 0.3. Okay? Now, very quickly, I'm going to allude to something that we'll work on a problem later, but how could I check to see if these are independent, right? We said they're independent if the conditional probability is equal to the unconditional probability, right? Well, here we found a conditional probability. So if the probability that somebody wants marijuana legalized, knowing that they're a Republican, if that's just the same as having no information, just what's the probability they want marijuana legalized, which we can see is 0.55. Well, those aren't the same, right? Those aren't the same thing. So we automatically already know these aren't independent events. Okay? We'll talk about this again in one of the problems later on, but this is just kind of, once we have a conditional probability, it's pretty easy to check if they're independent. Okay? So we found that was what? That was, here we go. Oops, if I select the whole thing. 0.3. Okay. And if this gets too small, or if you can't see something, make sure you let me know. I think it's just a little bit easier instead of switching back and forth to be able to see both of them at the same time. So what's the probability that an individual is not a Republican and does not want marijuana legalized? Right? So I could write this out in words, and that might be the easiest way to do it. So if I'm thinking about what I'm really trying to look for here, I'm saying, okay, what's the probability that someone does not want marijuana legalized and not a Republican, right? Well, if I'm writing this out in the context of kind of my just using a smaller abbreviation, we could think about really what I'm saying is if LM was wanting marijuana legalized, not wanting it legalized was just the complement, right? And then and not being a Republican would be our complement. Either way is fine. Like if you want to write out, using more words to kind of make it easier for yourself, that's fine. But we're looking for an intersection here. Right? This and this. So if we go up here, it should be pretty easy because remember, these top 4 left cells all represent intersections, right? So if I want the probability that no, they don't want marijuana legalized and they are not a Republican, that's simply identifying that one cell. So here, there's no real work to be done other than looking that up on the table. Generally, I probably would have put that problem a little bit easier, because, a little bit higher, because it's a little bit easier than kind of finding that conditional probability. But all we had to do on that one, once we realize it's an intersection, it's just going to be one of those top 4 left cells. Okay. So I already alluded to this one a little bit, but are wanting marijuana legalized and being a Republican, right, are those independent events? Okay. So the general definition we had for independent events, I already had it written down earlier, but I'll write it again. Is the conditional probability of A equal to the unconditional probability of A? Oh, a little crooked there. So we're looking for the probability of the same event when we're determining independence. Okay? So if I look at these possible answers, right, I can rule some of them out pretty quickly because I can't say yes or no that they're independent unless I'm comparing the conditional probability of an event to the unconditional probability of that same event. So here, I'm looking for the conditional probability of R, right? I'm still looking for the probability of R, I'm just conditioning on LM. So I should be comparing that to the probability of R. Well, I'm not here, so this doesn't tell me anything about independence, right? I have to be comparing the conditional probability to the unconditional probability of the same event, okay? Is that clear? Any questions on that? Okay. So I can rule out A. Here, I'm comparing the conditional probability of R to the unconditional, so that's okay. Here, I'm comparing the conditional to the unconditional of LM, and here's, okay, so we can only really rule out A here. So now I just need to check this, right? And it looks like I've got a couple kind of LM and R, but it doesn't matter either way I check this, right? So it doesn't matter if I want to do it as this. So I could do, I can compare that conditional to that unconditional, or I could do it this way, right? Because if being a Republican is independent from wanting marijuana legalized is independent from being a Republican, right? So I can use either one of these to check whether or not they're independent, okay? Now, I actually already mentioned, we had done some earlier work. We could actually save ourselves a little bit of time because in order to find this conditional probability, we already said earlier, well, that conditional probability is just the intersection divided by what we're conditioning on. So we actually had already found that probability earlier, right? So it'd be the exact same process, and this is just going to be 0.3. Is that equal to the unconditional probability of LM, which I think we said was it 0.55? So yes, they want marijuana legalized. Yeah, 0.55. Well, those aren't the same, so we would say they're not independent, right? They're only independent if this equality holds, okay? So here, it doesn't hold, right? They're not the same thing, so we would say no, they're not independent, okay? So no, they're not independent, and there, we already ruled out A, so if we're looking for an answer of no, we already automatically know B, it's B, but no, they're not independent because this conditional probability isn't the same as the unconditional probability, okay? Now, it doesn't matter either way you check this. I want to get through a few more problems, but what you could have done is solve for this conditional probability as well, and then see, is that equal to this unconditional? If you want to go through and do that work, you'll find the same thing, that those two things aren't equal and that they're not independent, but there's just, it doesn't matter which way you check it, you'll come up with the same conclusion, okay? Any questions on any of that before we keep moving? Okay. So this one, I think, hopefully should be easy, right? So, I mean, I'm not giving you an answer to the exam, but let's think about the definition of mutually exclusive, right? Mutually exclusive was when we have two things that cannot occur at the same time. So if two things can't occur at the same time, the probability of their intersection should just be, someone I think whispered it very, very lightly, but 0, right? If it can't occur, the lowest the probability we can see is 0. So we're looking for whether or not an intersection is equal to 0, okay? So I'm looking here, I mean, I can rule out some of these, right? Because unions don't make any sense for what I'm trying to check, right? If they're mutually exclusive, their union could still be anything between 0 and 1. But the intersection of those two things, there's no overlap, so that's the probability of 0. So here we can rule out B and D right away because they're talking about unions. We don't care about that. So we look at the intersection. We say, all right, either yes, they're mutually exclusive because the intersection is 0, which this doesn't even say, so actually we could rule out C, but just in case I would have had this in there and it actually made sense, well, we can actually go and check to see if the intersection is 0. Go back up to this contingency table. I guess we didn't have X here, but if we write that in, are any of those intersections 0? So none of these will be mutually exclusive events. So automatically we know if we don't see a 0 in that contingency table, then no, they can't be mutually exclusive because the intersection of those events isn't 0. It's not equal to 0. So there automatically we know A is going to be our correct answer. And if we go back here, which one was it? I think it was this guy right here would have been our answer that we talked about. Okay. So, I mean, if you look at that contingency table and you don't see any zeros, automatically you know when you're asked a question about are these events mutually exclusive, the answer for sure should be no if you don't see a 0. Now, if you see a 0, then you know the answer has to be kind of yes for those events, right? But if we're writing out why, it's because that intersection is not equal to 0. Okay. Any questions on that one? Yeah.
I'm getting kind of confused. Could you just like read the probability of like how do you say what intersection?
Oh, okay. So here R was being a Republican, and LM was if they wanted marijuana legalized. So you could write out Republican, and maybe LM is equal to yes here. So this is the probability of being Republican and wanting marijuana legalized is not equal to 0. In fact, it's 0.15 up here. Right? So automatically we know we can find intersections. They're just one of those top 4 left cells. So if it's not equal to 0, then they're not mutually exclusive. Double check. I don't have anything in the chat. Usually it flashes at me. All right. Okay. I'll kind of keep moving. I'm going to jump around a little bit. I think, I don't know if we'll get to this today. I might save this to do at the beginning of class on Thursday. This is some of that Bayes theorem. Kind of have that fresher in our minds because I think sometimes it's the harder thing. So I want to make sure we do that closer to when you're going to take the exam. But we'll kind of work through what, 10 through 13 on Thursday to start out for sure. Okay. Oh yeah, let's do one of these. So let's say we've got, This is actually an example that we literally used in class, but doing a couple things different with it. Okay? So let's say we have these different bonus amounts, right? And we have different probabilities associated with seeing each one of them. Okay? So if we think about finding the mean, just to kind of help out with that formula sheet, if I go down here, here's my mean and variance equation for finding the mean and variance of a discrete random variable. So anytime I have outcomes that have probabilities associated with seeing them, I should automatically be thinking, these are the two equations I need to use for the mean and the variance, right? Because I can't simply add these values up and divide by the number of values I have, like a regular mean, because 10 is way less likely than seeing 3 million here, right? And we can kind of ignore the millions, right? We're just putting M's on everything and ignoring the zeros, making it easier. So if I'm looking here, you know, I've got 4 different outcomes and their probabilities. The formula sheet tells me, take each one of those outcomes for X, multiply it by the probability I see that outcome for X, and then add them all up. So really what I'm doing there is what's the very first outcome that I see here? At 10 million times what's the probability that we see 10 million? 0.15. Add to that the next possible outcome of 6 million times the probability we see that 6 million bonus, plus the next outcome times the probability it occurs, and then finally plus the final outcome of 0 times the probability it occurs. Now usually you would think we have some kind of a denominator, but we said we're really just doing a weighted mean here, where the weights are our probabilities. So technically we have a denominator here, but it's the sum of the probabilities of every possible outcome for X, which if we add up the probability of every single possible outcome, those should just add up to 1, right? So essentially, we can ignore that denominator. And that's going to be the case anytime we're using these probabilities as our weights. I mean, you can even verify this, add up these probabilities here, and they add up to 1, right? But dividing by 1 doesn't change anything. Okay? So I think that one, if I remember right, is 4.2, I guess, million, right? So that one shouldn't be too bad. I think that's a relatively, you know, finding the mean of a discrete random variable shouldn't be the most difficult. Okay? Now here's where I have to do a little bit something different than maybe what we've seen on our homeworks or even having to work through in class, which is some of these questions will be linked. This is not as big of a problem for this first exam, more of a problem for our next 2. So what I'll start doing, because I don't want you to have cascading errors, right? If you don't, so the next one asks me for the standard deviation, right? If I'm finding a variance or a standard deviation and I don't have the correct mean, how the hell am I going to get the correct variance, right? So if I got 14 wrong, all bets are off on 15, right? So I'm giving everybody an assumed true mean. So doesn't matter what you found in 14, assume the mean is 5 million here. So we're all kind of starting off in the same foot, right? Also, every time I say that, I feel like it's not a saying, but I say it a lot. So, but we're all starting off in the same kind of level playing field. There we go. So we have this 5 million as our mean, and then we'll kind of work through and calculate the variance using that as the mean. Now, before we even start, I'm still finding a variance, right? It's telling me something about how much these outcomes vary, right, from this mean of 5 million. Which of these can I rule out looking at these answers? What's the lowest the variance or standard deviation can be? Yeah, 0, right? We said that it doesn't matter if I'm above or below, right? We're just getting a measure of how far away, right, in either direction. So our variance can't be negative. So we could, you know, well, this is a strike through here, right? Yeah, we could rule that out right away. Well, now, even if we don't know what we're doing, we have, you know, instead of 1 out of 4 shot, if we guess, we got a 1 out of 3. So one thing with those multiple choice portion of the exam, I always mention this to students, you know, if I don't know what to do on a short answer, what do I do? Right? I'm getting 0 points probably, right? If I don't know where to begin or what to use. But at least on the multiple choice, even if I'm not sure, like I know that my answer I'm getting my calculator is wrong and I can't figure out exactly what it is, at least I can rule some of these out and take a very, you know, a more educated guess. And in fact, sometimes I'll write these in such a way that if you remember all the principles about that one statistic, you could rule out all but one of the answers. Now, I don't do that in every question or like all the time, but there may end up being one question like that in the exam, right? Because knowing these principles is important, right? I mean, the computation really, to be completely honest, we're going to be having a computer or we're doing it with a calculator, right? We're not actually doing it in our head. But we need to know that if we entered something in wrong to the computer or the calculator, we can like catch that, like, you know, that error, right? So that's kind of one of those scenarios here. So we have that mean of 5 million. Let's go to the formula sheet. We've got our discrete random variable equations here. I even kind of group them, right, with these little brackets. So here's our variance equation. We'll take each outcome, subtract the mean, square that deviation from the mean, and then multiply it by the probability we saw that outcome for x. Okay? So that's the general form of the equation. So we're going to apply that to our data set here. So the very first outcome we could see when we're calculating the variance is that 10 million. We'll subtract that assumed true mean, and this is kind of the mean that we were given, of 5 million, and then multiply by what's the probability that I saw that outcome of 10 million, so it's 0.15. Add to that the next possible outcome of 6 million, subtract that mean of 5, square it. What's the probability that we saw 6 million? Looks like here it's 0.25. And then I won't say the other ones out loud. I'll just kind of jot them down real quick. So if you're working along with me, you could write this out completely. So 0 minus 5 squared times 0.2. Right? So that should give me my variance. All right. Yeah.
Could you make it just a little bigger?
I think, oh, actually, you know what I can do maybe? I can't make the box bigger, but I can make this bigger. Yeah. I don't think I can make it any bigger. I don't know why Zoom limits that capability. I feel like it would be convenient not to. So we could do that, enter it all into our calculator, or kind of another easier way maybe to do this, and obviously you aren't going to have a file that you can do this to, but you could create your own column, like write it down. I've got these different outcomes. I could go through and like write down each one of these. So 10 minus 5 is 5. Squared is 25. 25 times, whoops, 0.15, what should be 3.75. Then the next one, 6 minus 5 squared is 1 times 0.25, it's 0.25. And I could calculate each one individually and then go back and add them all up. Sometimes that's a way that's like easier to not make a parentheses error in your calculator. So if you've got a little bit extra time, or if this way is easier for you, kind of just create your own column where you're writing down that deviation squared times the probability of occurring for each one of these outcomes, and then go through and add them all up. Right? It's the same thing. You're just kind of breaking it down step by step. Okay. All right. Any questions on that? Okay. I have no idea what this is. I got the answer to here, but let's see if we can work through this real quick. So we got 3.75 plus 0.25 plus what? 3, so 2 squared 4, 4 times 0.4 plus 25 times 0.2. So it should be 10.6. But if I answered, sorry, 10.6. But if I answered 10.6 to this question, why would it be wrong? What am I actually asked to find? What is the, huh?
The bonus amount?
So the bonus amount, but I'm not finding the variance. It actually asks me to find the standard deviation, right? So what's the only other step I should have to do? Take the square root, right? So if I have the variance, right, that's sigma squared, the standard deviation will just be the square root of the variance, or the square root of 10.6, which I'm guessing is about 3.25. Okay? So make sure you read these questions carefully, because in order to find the standard deviation, you always have to calculate the variance first. So you don't want to forget that last step if the question is asking you for the standard deviation. Okay? Now I'm trying to hammer this idea home. It might seem trivial, but once we get to some other stuff after this exam, like we use the variance sometimes in the standard deviation in others, so it's really important that we know like which one we're using and how to find one from the other. And Any questions on that before we keep, oh, that wasn't on the screen, sorry. There we go. Before we keep moving here. All right. So, just bold this one too that we found earlier. So here's one, and I'll give you we'll work through this question, but then I'll go through a different one that might be a little trickier. So what's the probability that a trader gets a bonus of amount of at least 3 million? So i.e., what's the probability X is greater than or equal to 3 million? Well, if I go up here, the probability they get 3 million is 0.4. And then everything that's greater than that, well, they could have gotten 6 million with a probability of 0.25 and 10 with a probability of 0.15. So all I have to do is add those probabilities up. So if I'm writing this out for like any example that we could see. So what we were asked to find was the probability X is greater than or equal to 3 million, right? So if we think about this as event A, what we want to do is find every outcome that fits into event A and then add the probabilities up of all those outcomes. We did this a lot more with like the binomial distribution, and I showed you some examples also with the Poisson where we do this. So what I really want to think about is what are all the possible outcomes that fit this criteria for this variable? Well, the very first one is X could be equal to 3, plus the probability X could be, what's the next value we could see? 6, plus the probability, the next value that we could see here is 10, right? This is kind of a goofy one because the jumps aren't like one integer, right? It happens to be kind of these larger jumps. Well, I know the probability of seeing 3 is what? 0.4, of 6 is 0.25, and 10 is 0.15. So it's simply just a matter of adding those together. Okay? So I think this should be 0.8, right? Now, what if I instead, this one would have been a little bit trickier. What if I wanted the probability that X is, let me see here, less than 10 million? What's the very first outcome that would have fit this criteria? 6 million, right? There's no equality, so I don't want to include the 10 million. And the very next outcome I could see is that X is equal to 6. And then after that, X is equal to 3. Then X is equal to 0, right? So be careful with the equalities, right? Or when you have these ones that have jumps, you have to go to the next lowest outcome you could see, right? It's less than 10, so you have to look for the very first outcome you could see that is less than 10. Any questions over that one before we keep moving? Yeah.
So like on the Connect assignment, there was one like this that I considered like X, if maybe it said like 10. But the different one though, like I had to calculate an average or something like that. Is that going to be on the exam? Like that's something.
So we did calculate the average here, right? That's what we were doing for 14. So you could find the mean or the average, right? And we talked about kind of wherever it was, right? That was simply going through every single possible outcome and multiplying those outcomes by the probability they occur, and then add them all up. I'm not sure exactly what question you're talking about. Was it maybe a binomial problem? Okay, we'll actually do that next. So trying to think of the other thing. So some people ran into problems with some of the Connect, but I don't know if I want to take time to if you have a question on the Connect, send me an email because I won't. I know what you might be talking about, but I'm not going to push you that far in the exam. So I want to make sure that sometimes the Connect homeworks, well, I say sometimes, a lot of times the Connect problems in like Excel will actually be harder than what I ask you on the exam because you're not constricted to time, you're not constricted to like me as a resource, things like that. So, all right. Make sure we don't have any questions. All right, so we'll end, we've got quite a few, so it's not like we're ending right this second, but we'll end today's class with some binomial work, right? So let's say we've got what? 40% of credit card owners carry a balance from month to month. Suppose we interview 10 credit card customers. Also, I'm sorry if I say the word balance wrong. I got like reading by a student once that I guess I don't say it like a lot of people from Indiana. So I apologize in advance, but We've got 10 of these customers. The probability that any one customer kind of carries this balance is 40%, right? So we automatically know they either carry a balance or they don't, right? It's a 1-0, right? So we have a binary kind of success failure. We've got a binomial distribution, right? Binary, binomial. So the probability of success in any one trial will be that 40%, which if we write 40% as a probability, that's 0.4. Right? How many people are we looking at, or what's our number of trials? We're looking at 10 customers, right? 10 credit card holders. Okay? So here, if I wanted to find the mean, or the expected number of people who carry a balance, right? Well, out of 10, if on average 40% of people carry a balance, what would the mean number of expected people be here? What if I had 100 people? 40% of people usually carry a balance. On average, I would see 4 in this example. Yeah, out of 100, 40, right? Really what we're doing there intuitively is just take the number of trials, multiply that by the probability of success, okay? We look at our formula sheet. Here's our binomial function equations. Here's that probability mass function. Here's the equation to find the mean of a binomial. Here's the equation to find the variance of a binomial, which I didn't ask you in that, but hint, hint, I could ask you that on the exam. And it's really just going to be as simple as, well, I've got the equation right here on my formula sheet. I've grouped these together. If I have this, right now, or I print this out right next to it, binomial, right? These are my binomial functions. Here's how I find the variance of binomials. So here that would be what? 10 times 0.4 times 1 minus 0.4. And that should be something that we can get entered into our calculator pretty easily. Okay? And here we did what? 10 times 0.4. So on average, 4 of these customers carry a balance. Right? Any questions on that, or anything else I could ask you? Or also, if I can ask you for the variance, I can also ask you for the standard deviation, which, as always, just take the square root. Okay, that's the only additional step there. All right, so we got 4 there. We got our kind of mean number. Okay. Oh, I guess I did ask you for a variance. So what's the variance here? So it'd be what? 4 times 0.6, so what, 2.4, if I'm doing math in my head correctly? If we actually go ahead and compute that out. Right? All right, so a little bit more difficult. What's the probability that exactly 4 customers carry a balance? So what I now want, if I write out what I'm looking for, is what's the probability x is equal to 4? Okay. Well, now first of all, which of these can I rule out right away? C, because it's greater than 1. Probabilities have to be between 0 and 1, right? If I'm looking at the other ones, one of these doesn't make a lot of sense. Which one do you, I mean, this won't be the case in every example, but what's another one that's probably pretty safe to rule out here? You could argue 77, but there's a stronger argument for another one. Think about what the mean is, right? If the mean is 4, that's the value that we should see most often. So if I want the probability of seeing exactly 4, if it's what I see most often, should the probability be as low as 7% or 0.07? Probably not, right? I mean, I really can only see 0 through 10. I mean, and I'm sure seeing 8, 9, or 10 is pretty low. So 0.07 here seems really low. But on the flip side, 0.77 seems pretty high, because even though on average I see 4 and that's the most likely outcome, well, seeing 3 or 5 isn't going to be that crazy in a group of 10. And so if I've got outcomes that are going to be fairly likely around 4, well, if I've already got 0.7 here, I only have 0.2 left of probability to spread out across all the other outcomes. So if I'm just going to take a shot in the dark on this one, I'm going to guess it's B, right? I haven't computed it, and it's a little bit risky to maybe rule out A and D, but at least intuitively, it doesn't make sense that it would be those answers. But we don't have to guess, right? We have this probability mass function, okay? So our n was 10, our p was 0.4 and our x is 4. So we're just going to write this out. So n factorial over x factorial, right? I can just follow along reading this equation, writing it out, plugging my numbers in. N minus x factorial times the probability of success to the x power times 1 minus the probability of success to the n minus x power, right? Now, once again, before you enter this into a calculator, I would recommend like simplifying these. So this is 6, this is 6, this is 0.6, right? Well, why, you know, risk putting a parenthesis in the wrong spot when I don't need to? Okay? But from here, it's really just a matter of getting this into our calculator correctly, working through some of these examples to make sure that we're comfortable doing this. Okay? Now, one thing I could do here is if I write this out to make it a little bit easier on myself. Right, I'm just writing out what each one of those factorials would be. Right, everything past 6 here would cancel. So it's really 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. Okay. So even if I can't find my factorial button and I'm freaking out when I'm taking the exam, which hopefully all of you have kind of worked at finding where that's at in your calculator that you're going to use at this point. A lot of people have been coming up to me. There's one, and I said it's like a probability button, but it just says PRB. And if you click on that and go over, like on a smaller, not a TI-83 or whatever, it's usually just under this thing that says PRB on it. Okay. But if you haven't found it and you can't find it, email me, let me know so we can figure that out before you take the exam. And don't email me like Sunday night. Okay. So, all right. So we got that. We'll kind of plug everything in there. I'm sure we can verify this. I'll just verify the 10 times 9 times 8 times 7 divided by 4 times 3, oops, times 2 times 1, times 0.4 to the 4th, times 0.6 to the 6th. Sure enough, we get 0.2508, which, if we round, 0.25. Okay. Oh, and this was a little bit off the screen here. If that happens again, make sure you let me know. So, this also brings up another good point. You may on some of these get an answer like that and was, what did I say, 0.2508. Whatever I display the answers to, you're going to have to round to that decimal, right? So everything here, right, we've got out to the second decimal. So whatever answer you get, you're going to have to round to the second decimal. Now, I'm never going to try to trick you and give you like, I don't know, what would be really mean? Doing something like this, 0.250 and 0.251 or something like that, right? And making you make a rounding error, get the wrong. Never gonna do anything like that. So kind of just use conventional rounding rules and you should be okay. But just to hopefully alleviate some concerns, I'll never do something like this. Where are we at in time here? Oh, good. All right. Any questions on that one before we keep moving? Now remember, one thing I didn't do here, but I could have done in the exam, is done something like, instead of 10 customers, what if I did something like this? What if I did, I had 100 customers, and then I wanted to know the probability that 4 of them carried a balance, right? So I plug everything in, 100 n factorial over x factorial, n minus x factorial, 0.4 to the 4th times 1 minus 0.4 to the 100 minus 4. We don't worry about this portion because I can enter that in my calculator and it can handle it okay. But this portion, if I try to put into my calculator 100 factorial, it's going to yell at me, right? And say, I can't do that. But this is where writing out what the factorial looks like can help, because right, all the way down to 1, and then 4 times 3 times 2 times 1. This would be what, 96 factorial? Well, notice here, 96, and everything below it would cancel, and I can actually get that entered into my calculator. Right? I'm very likely to ask you maybe something that looks like this, right? Only because, it's good to know ways to circumvent the limitations of technology. Right? If especially when we try to exactly put a function into Excel or our calculator, sometimes we can run into some of these issues when in all reality, If we did the cancellation, there's a much easier way that we could do it. Any questions on that before we keep moving? Okay with that? Okay. This last one. What's the probability that at least one customer carries a balance? One thing I hate about math is not being able to lick my fingers to like pull paper apart, or I'm gonna go on a little bit aside, but also like when you go to the grocery store, you have to put like vegetables in those like plastic things. It might be the most aggravating thing ever. But there is a hack. If you go to like the ones that have, they spray the water on them, like find something nearby and then kind of just touch, which is probably not safe at all. It's probably even worse. But here we go. So what's the probability that at least one customer carries a balance? What we really want there is the probability that X at least one, so 1 or higher, right? Greater than or equal to 1. And to be honest, on the exam, I probably on this one, because, you know, I don't want, English sucks sometimes, and I don't want like a misinterpretation here to be like, oh, at least 1 means greater than 1. So usually I would do something like this, where I actually, no, where's the symbol? I would actually type that out so that we're really clear where that equality is. I was writing these practice exams quickly, so, but usually on an exam, I'm going to give you something like this so that that doesn't cause any concern. So if I just take a step back, I could probably make this one easier. I'll end up working it all out for you, but we're still working with that same example where the average number of people that carried a balance was 4. Right? So we then said, okay, what are some other likely outcomes? Well, 3 and 5 will be pretty likely if 4 is the average. Even 2 and 6, right? So if we're thinking this range includes what? Probability that X is equal to 1 plus the probability X is equal to 2, all the way up to the very highest number of successes we could see, which is 10, which included all those really common outcomes for us to see. This probability is probably going to be pretty close to what? 1, right? It's going to include almost all of the high probability outcomes. And not only that, it includes most of just the possible outcomes we could see, right? The only outcomes it doesn't include is 0 and 1. Right? Or sorry, actually 0, right? Because the equality is there, so it includes 1. So if I'm guessing here, I don't know exactly. It's got to be A or C, though, right? It's got to be something really pretty close to 1. But, you know, it could be as low as 0.92. I don't know, you know, so let's check, right? So instead of doing this, I can't, every time I'm looking for a probability, I have to use that probability mass function. I'm not going to expect you to do something like that, right? But what I might expect you to do is, if we think about this as event A, what's another way I could find that? Well, that would just be 1 minus the probability of the complement. What's the complement of X being greater than or equal to 1? X being not less than or equal to, simply less than, right? That's important. We need to make sure that if the equality is in our event, then the complement we don't include the equality on, okay? Well, what's the only, well, I shouldn't have said only because I probably already alluded to what the answer is, but what's the only outcome that fits this criteria? The only value that would be less than 1, yep, probability X is equal to 0. And then from there, it's just a matter of, we've got our n was 10, now our x is 0, n minus x, probability of the x times 1 minus the probability to the n minus x. Oh, I just wrote p in there. There should be a 0.4 right there, right? Oh, sorry, there we go. So I just wrote that out in the use that probability mass function, plugged all my values in. Now I can make this a lot easier because if we remember, what's anything to the 0 power? 1, right? I don't know if he's here today, but someone was in class last week, the day after the snowpocalypse, and when I said this, they like checked me, look, yeah, they're a skeptical look, and then I saw them enter things in their calculator. I was like, oh, sure enough, I did. But anything to 0 power is 1. Anything, if we have a 0 factorial, that's just kind of a unique property where that actually ends up also being equal to 1. So that's kind of a weird one, but 0 factorial is also equal to 1. And then here, 10 minus 0 is just 10 factorial. 10 factorial over 10 factorial cancels. This whole fraction is just 1. This guy right here would be 1. So really all we have to do is take what? We simplify this, 0.6 to the 10th, and that will be our answer. So if we take what? 0.6 to the 10th power, we get 0.006, right? So 0.006. But remember, that was just giving us the probability x is equal to 0. We still had to subtract that from 1, 0.994, or if we round this, 0.99. Okay? Which, yeah, this is really close to 1, right? From going all the way back to where we started the discussion. Oh, sorry. Yeah, I told you guys, I tell them I keep, this is bad. Oh, it's because I zoomed in. That's why I keep thinking I have more space. But 1 minus 0.006 ends up being 0.994, which we just round to that 0.99. Okay? Any questions over that? Okay with that one? All right. Let me think if there's anything else I want to do here. Still got 15 minutes. We'll make sure we get through as many of these as we can. Go back and do some easy ones just to kind of refresh our memory on some of this. So if I go all the way back to problem 1 in this exam, okay, what's the mean weight of the players in this data set? Right? So I got 5 different players. I'm told it's a sample data set. So this one, every semester I say this. Actually, no, not in the fall. Was it in the fall? I think yeah. So last semester was like the first time I had every single person in all my sections get this right. But everyone should get number 1 right, right? I can guarantee you I will ask you for the mean of a small data set on question number 1 of the exam, okay? All you have to do, look at that weight variable, add those values up, and divide by the number of numbers we have. So 231 plus 191 plus 225 plus 258 plus 232, divide by 5 numbers, right? So divide by 5. I think if I remember right. Well, first of all, actually I can figure this one out even without doing that, right? Which of these answers could I rule out right away? D for sure makes absolutely no sense, right? How could someone even weigh 1,137 pounds, right? And play basketball, I guess I should say. Why can I rule out B as well? It's higher than, the heaviest person in this data is 258 pounds. So how does the middle point of the data exceed the maximum? That makes no sense either. So we could rule out B too. And then same idea with C. Nobody weighs less than 191. How is the middle of the data 80.4? So I didn't even have to really calculate this one. This is an example where I could have ruled all 3 of these out. I know the answer has to be A here without even touching my calculator. Okay? And once again, that's just like the principles and thinking about what the statistic we're calculating is actually telling us. Okay? So here's one, and I probably won't work through all the kind of completely write this out. It's very similar to what we did with the discrete random variable variance, except for we don't have to multiply by the probability. I'll give you an assumed true mean. So let's say the average height is 80.4. Okay? I go to my formula sheet. If I want to find the standard deviation, that's going to be all the way back up here. Here I've got my variances and I've got my standard deviations. Okay? Now all the standard deviations are taking the square root of the variance, but there was one key difference that we had between a population variance and a sample variance. So here I believe the problem states this is a sample of the roster, right? It's not the entire roster, it's 5 of the players, okay? So we actually know we don't have a population variance, we're going to be calculating a sample variance and then a sample standard deviation. So we're going to go through every single observation, take the value, right, the first person's height, subtract that mean height of 80.4, and then square that value. Then go to the next person, take their height, subtract the mean of 80.4, square that. Do that for every person and then add them all up. Once we do that, we're then going to divide by n minus 1. Right? So sometimes the reason why people get number 1 wrong if they calculate, is if you try to calculate the mean, we're always dividing by the number of observations for the mean. It's just with the variance, we account for the fact that if we have sample data, we want to make sure that we kind of inflate that variance a little bit and divide it by a slightly lower number. And this becomes a little more clear when we do things like confidence intervals and hypothesis testing. So instead of dividing by 5 here, once I go through that process, I'd only be dividing by 4. Right? So kind of pointing out that's a key difference when we have sample data. Make sure you don't divide by the number of observations, but you divide by the number of observations minus 1. Okay? And then we would have had to take the square root here because it asked us for the standard deviation. Right? Just kind of ending on some of these principles. I'm not completely working through this one. One thing I actually will do, just for those of you that might not even be in class, so probably isn't as relevant for you who are here today. I'm a little more than halfway through. I'll probably get it done this afternoon. Just like this practice exam, but worked out in Word. So like having all the functions, like the general form and then the numbers plugged in so that you could go through and follow in Word as well, as opposed to just looking at the videos of us working through these. What if I wanted the median height of this data set? So if I'm looking at height and I want to find the median, what do? So how do I find the median? The median is the point at which 50% of the data is above it, 50% is below it. Okay? So what was the first thing I typically should do? I don't have to. I could arrange them, right? It probably makes it a little bit easier when I have more numbers. Here I only have 5, so it'll probably be okay. But once I had them arranged, then what did I start doing? I crossed off the highest and the lowest, then the next highest, next lowest. So here, right, the highest value is 84, so we cross that off. Lowest value is 76. Highest value is 83. Next lowest value is 79. Where is it? There you go. And I'm left with one value, which is 80, which that would be my median. Right? The only kind of difficult thing would be, there you go. I don't know, let's say we have, I don't know, some other point guard on the team. And let's do height of 82, I don't know, 200, right? If we get left with 2 values, right, we have an even number data set, and I have 2 values in the middle, how do I then find the median? Simply the average of the 2. So 80 plus 82 divided by 2. Right? So 81 here. Right? That'd be the only other wrinkle you could kind of see without being asked the median. Okay. Any questions on that? Yeah.
I don't know. Did you say the answer to number 2?
I didn't, but if I'm gonna go out on a limb and guess, I think it might be 3.12. I think I have the answer key pulled up here. Yeah, if you actually go ahead and calculate that, yeah, 3.2 or 3.21. I said 12, 3.21. Yep. Any other questions? We got a little bit of time here, so we'll work through this last one. Okay. So number 4. Okay. So I've got all these different mutual funds I've invested in and the return rate on each one of those. Right. I invested different amounts in each one of these, and I want to find what's my mean return for this entire portfolio. Okay. So if I'm looking for the mean return, I'm looking for kind of what the mean of the return variable is, but weighting it by how much I invested in each one of those stocks. Because this, well, what should I say? This negative return down here doesn't have as much of an influence because I only invested $100,000, whereas these really high returns, I invested a lot more money into them. Right? So if I'm looking at these here, these possible answers, well, right away, if I'm looking for the mean return, it has to be somewhere in between my lowest and highest values. So somewhere in between what, 0.19 and negative 0.02. So right away, B and D doesn't make any sense for me here. Right? I'm not looking for the mean amount invested. I'm looking for the mean return and using the amount I invested as my weights. Okay? So right away, I know it's either going to be A or C. Now, which one of those is it going to be? I can't really, there's no principle. Both of them are theoretically possible answers here. Right? But what I can do is I go to my, oh, come on. go to my formula sheet, scroll over here, go down a little bit. Here's my weighted mean and variance, right? Now, this is, we said the discrete random variable, it's similar to a weighted variance, but a little bit different because now I really have to focus on, well, what's the sum of my weights there in the denominator? Because before the sum of the weights, the sum of my probabilities was 1. But now my weights are the amount invested. Those don't add up to 1. Okay? So I'll go through every single X value I have, multiply it by its weight, add those all up, and then divide by the sum of my weights. Okay? So if I look at this here, and I'll write that equation down in just a second so we have that. To find that mean, I'm taking the weights of each observation times the value I see for X, add those all up, and then divide by the sum of my weights. So first outcome I see is what? So the weight is, and I'm going to put K, just so I don't have to have a whole bunch of zeros here and take up a bunch of room, multiplied by the return I saw from that mutual fund. Add to that, I invested 200K in the next one, and its return was 0.1895 plus 200,000. Whoops, this one had a negative return. And then plus 100,000, and that had a return of 0.0342. So that's my numerator. I know it's not all on one line there, so I apologize for that, right? That's my numerator. But my denominator is the sum of my weights, which if my weights are the amounts invested, which one did I get wrong here? Yeah, sorry, this one should be 100K and this one should be 50K, right? Okay, sorry about that. I was looking, I went up a line. Okay, so the sum of my weights will just be adding up the amounts invested here. So 500K plus 200K plus 100 plus 50, right? I'm just using K there so I don't have to put 3 zeros in every time. But if you're doing this on your calculator, you need to put those zeros in, right? I think if I do this, I don't remember what the answer is. Well, I'll work along with you guys. So we've got what? 500 plus 200 negative 0.0259 plus 50 times 0.0 divided by 500 plus 200 plus 100 plus 50. So we get 0.1309, right? Which if we round that, 0.131, okay? Any questions on that one? Okay with that? Sure. Oh, I had a question come I didn't see earlier. Someone said 4. I was probably answering my question. All right. If there's no questions, I think we'll get this video posted. We'll have a few more problems on Thursday to work through from this exam. It'll give us a review of like Bayes' theorem and kind of those, that topic. And then I'll probably just ask you, like, do you guys have any questions? Like, do you have questions on practice exam A? Like, we'll start with those. I don't want to just start working through ones that you guys already know how to do. Whoever's here, whatever questions you have on practice exam A, or even if you want to bring a question in from the Connect or some old, I don't know, online quiz question, we'll kind of work through those in class on Thursday, okay? Any other questions for me? All right, so make sure you get those homeworks done. I've seen a lot of people already kind of turning those in and doing some good work, especially in the Connect. Make sure you get those out of the way as early as possible so you can start studying for that exam. Like I said, if you want to get the homeworks done first, and you do want to kind of have this weekend a little bit free, maybe on Sunday, you can take the exam as late as kind of Sunday night, okay, or the end of the day. All right. All right, I'm glad the new room hopefully kind of worked out better, and I will plan on seeing everybody on Thursday.